Hey guys, it's Jackson here from Titanic Games, and today we're going to be continuing our survival game series, and we'll be going about adding some kind of cool post-processing effects and in-game effects that will create our heat stroke and hypothermia kind of status effects. So here's our heat stroke one. Basically, as your temperature increases, it applies this effect, and as it goes out of the heat stroke range, then it decreases. And here will be our hypothermia one. Okay. So again, same thing except just the opposite way, right? We apply these effects. Now this is very drastic. It's being applied very aggressively here. Our fall off will be a lot smoother, so just be aware of that. So anyways, let's go ahead and get to it. Now the first thing we're going to do before we get too far ahead of ourselves is we're going to go find some textures that we'll be able to use for our post-processing. So what you can do here is go to good old Google Images and just type in something like flame texture seamless, and then try to find a texture that you'd like to use as kind of the overlay that you'll have for your post-processing effect. So the one that I went with specifically was this one here. Just go ahead, download it, whatever. But I recommend that any images that you download, that you change its resolution to be a power of 2. So what I did with this one is I downloaded it and then scaled it up to 1024 by 1024. Okay, you can do that in Photoshop, Paint, GIMP, whatever. Then we also want to look for an ice texture. So unfortunately I don't remember exactly which one I picked here because they all look so similar, but basically go ahead and find one that you like, or I will be providing both of the ones that I used with any edits that I did to them in the description below. So go ahead and look at the link there. You can go download them so that you can follow along exactly. But definitely feel free to pick out your own. Okay. So, anyways, once you've got your textures, we're gonna go ahead and come into the content browser, and we're gonna right-click, create a new folder called Materials. Open this up. Right-click, create another folder called Post. There we go. Oh my lord, I can't spell today. Post-process. So this will be for any kind of post-processing materials that we have. Okay, so create one more folder in here just called textures, because I want to make sure we separate our textures from our actual materials here. Okay, so we'll come all the way into textures now, and then we'll right click, go to import, and now obviously I'm already here. So go ahead and just locate wherever yours are, and then we're going to take them and import both of them. Alright, now if I open these up really quick, you can see here's this texture. It's a 1024 by 1024. Okay, if you don't like how big that is, you can definitely, thankfully with power of 2s, you can kind of give it an LOD bias right away inside the engine, and it will act as if you have kind of scaled it down out of the engine, I guess. At least that's my understanding of it. So there we go. We have our two materials, or excuse me, textures. Okay, there's our fire one, just so you look at it. Okay, we'll go back out here. I'm going to create our material. So create this guy. I'm going to call it M_blend effect. Okay, we'll open them up. Now, before we get started, I just want to preface this by saying that I am by no means a master at creating materials. Okay, everything I'm about to show here is stuff that I've kind of gleaned from other tutorials and just answers to questions on the answer hubs and forums, etc. Okay, so you could probably find better ways to do this, if you know what you're doing. But this is just one example of a way that I think looks pretty good. So with that said, let's go ahead and continue. So first thing, we want to make sure that we take or select our little guy here and go to material domain and change this to post process. Okay. Now this only leaves an emissive color, which is totally fine. So next, what we want to do is we're going to right click and add a scene texture. And what this does is it allows us to access, or at least put different textures on the screen. At least that's my kind of understanding of it, I guess. But specifically what we want to do is come over here to the details, click this drop down, and go down to post process input. Okay, so for the post processing effect, or for the pass rather of post processing, it will give us the color, the size, and the inverted size of the texture, I guess. Okay, now we're specifically going to be working with this color node, but we'll kind of get to that in a second after we've added some more stuff. Now, next what we want to do is we're going to right click and search for texture sample. Okay, so we've got this texture sample, and we're going to take our texture and we're going to look for just one of the two that we imported. So I'm going to go with the frost one, okay, because this is going to be sort of a master material, if you will, that we'll simply create dynamic material instances of inside of our character, and we'll be able to kind of swap out our textures and values, etc. So since this is going to be dynamic, or a master material, we're going to right click, convert this texture to a parameter, and we're going to change its name here to blend texture. Okay. Now next what we'll do is basically, since we're going to be working with this color node, okay, post-processing is a vector 4, okay, and by default the textures or texture samplers are vector 3s, so we need a way to convert between the two. Just to show you what I mean, so let's add a linear interpolate, and I'll explain what this does in a second. And then we're also going to plug in B here. We'll give it like just some stupid, oops, I didn't mean to hit the console. I'm just going to give it a simple value here, and if we plug this in, you'll see that it gives us an error. Right, it's saying arithmetic between types float4, which is this, and float3 are undefined. So we need a way to convert this into a float4. Okay, how do we do that? Well, it's really simple. All we do here is we drag off and say break float3 components. So we break it into its individual channels. Okay, and now from the B, we're going to drag out and say make float, but this time we want to make float4. Okay, since we're doing arithmetic between two vector 4s. So we'll plug in our RGB like so. You could probably just plug in the individual channels without breaking it, but this is just the way I like to do it so that I know explicitly what I'm doing here. Okay, so we've got that. Move that up a little bit. Okay, perfect. So now what we need to do is we're going to add a scalar parameter so that we can control the alpha of this texture from during in-game play, basically. So what we'll do is right click, look for scalar parameter. Okay, I'm going to name this guy alpha, and we're going to plug it into the alpha. And there we go. That's all we need to do. So a default value of 0 is perfectly fine because we don't want it to start out showing up at all. Okay, so this will work out great. So next what we're going to do is add another lerp off of color. And I forgot I was going to explain this. So for those of you that don't know what a lerp is, or a linear interpolate, is essentially it's a node that basically blends or interpolates from A to B based on a value of alpha, or a value C. Okay, so alpha is essentially, you could think of it almost like a percentage, right, going from like 0% to 100%. Okay, when it's 0% it's A, and then when it's 100% it's B. Okay, but this works on a like a 0 to 1 scale. Okay, 0 being 0% and 1 being 100%. So it's kind of a way you can think about it. Okay, so we'll only ever be going between 0 and 1. All right. Now for here, we don't want to plug this into emissive. We want to plug this into B, and then we'll want to plug this into emissive because we're going to be applying a sort of gradient to our texture to give it a nice kind of blend. Okay. So what we'll do for that is we're going to come down here, right click, and we're going to search for, we want screen aligned UVs. Okay, so this will take in some texture dimensions and it'll output us with some UVs, some screen aligned UVs. So let's handle the texture dimensions really quick. So this takes in a vector 2, and what it is it wants the resolution of your texture. Now I don't know if there's a way to get the dimensions of a texture from within the material editor here. If there is, I'd love to hear about it, but this is kind of the method that I'm using. So we'll drag out and say make float 2. Okay, and then from here we're going to right click and add a scalar parameter. We'll go ahead and duplicate that really quick, hook this guy up. Okay, now for this first one, we're going to call it let's call this image U, or we could just call it U, or maybe that's not really descriptive enough. We'll call it texture U, and then this guy, come on, we'll call it texture V. Okay, now we'll give each of these some defaults, and the defaults we'll give them are whatever our dimensions are for this texture. So we'll go find our texture, open it, and you'll see here are the defaults, right? It's 1024 by 1024. So we can go back into our blend effect, take this guy, change his default to 1024, change this guy's default to 1024 as well. All right, there we go. We have our texture coordinates set up so that we're properly aligning our UVs. Okay, now what we'll do is we'll take this little ratio, or excuse me, not ratio, but the the percentage of our UVs, and we'll run this through a radial gradient exponent or exponential. So this will help us create a radial gradient. Okay. Now center position, we can leave that variable alone. It's set to 0.5, which is perfect. Radius and density, however, are the two that we're going to be concerned with. So again, we're going to create some scalar parameters so that we can change these values if we need. And we'll just call this one radius. Okay, or you could call it gradient radius. That might be a little better. Gradient radius, not gradient radius. Gradient radius. There we go. And I'm going to set this to like a default value of how about 0.6 maybe. All right, and then we'll duplicate this and we'll call this next one here gradient density. Okay, and we'll play around with these values so you can see kind of what they do, so you have a better understanding of how you can use them to influence how your gradient looks. Okay, but now from this, what this is going to do is it's going to kind of apply a gradient that so if we look at our screen here, right, if you guys can see my mouse here, what it's going to do is it's going to apply a gradient that will filter out the edges of the texture first, and then kind of come in. Okay, so it'll make the edges transparent as it fades in, okay, as it gets more dense and the radius shrinks. Okay, but so we want to flip that. Okay, we want it to fade from the middle first and then out to the edges. Okay, so we'll take that and say 1 minus, not a component mask, it always does that. Just hit the 1 key and that will give you your 1 minus. Okay, and then we'll take that, plug that into our alpha of this lerp, and there we go. That's really all we need to do. Now you can definitely add more controls for this if you want. Like you could multiply this by say like a vector 3, which you could then use to, I don't know, enhance the color of the texture, for example. Or you could plug in some texture coordinates here to stretch or shrink the texture on the screen. Just stuff like that, really. But for all intents and purposes, it's good to go. So we'll just tidy up a little bit, and we'll go ahead and hit save. Okay. So let's go ahead and just test this out really quick to see what's going on. Okay. So we'll come into our materials, post-process. Now I'm going to right-click on it really quick and just create a material instance. Okay, we're not actually going to use this, but it's just for testing. So we'll go to our post-process volume, go under settings, come down here to blendables, and we'll add a new element, and then we'll choose asset reference. Okay, so now we can take our instance, just drag that guy over there. All right, now let's go ahead and try this out. So I'm going to open this up. I'm going to undock it because you kind of want to see what our texture is doing a little bit. Here we go. Okay, so now we can edit these and kind of see the effects in real time. So first we'll just look at our default values. So I'll take our alpha here, and as we increase the alpha, you'll see it starts adding the effect. Okay, so obviously there's a problem here. Problem being that our gradient density is not working correctly. Okay, let's go back into our effect really quick. And what we want to do is take gradient density. We're going to set this to a value of say 2. Okay, and I think that should be it. Oh, whatever, we'll just go with it. I'm assuming everything is fine now. So we go ahead and start increasing this, and you'll see that it's kind of fading out. That, well, as you see, if our alpha goes above 1, it starts to get a little intense. But as you can see, as it goes from like 0 to 1 ish, and we can actually add a clamp there so it's a little easier to test. We'll go back to our value here, say slider min 0, slider max 1. Okay, now we hit save there, and that will be good. Okay, so now we can only slide between 0 and 1. Alright, so there's our full-on effect, right? So with that in mind, right, what I would say is go, for testing out how you want it to appear, right, find some values that you like. Okay, so this gradient density, as you increase it, it makes the cutoff a little harder, but it also makes it fade out farther. If we set this back to its default, we can mess around with the gradient radius, right, which changes where it starts, where the gradient starts, I guess, cutting out. So yeah, really just a couple little things you can play around with. Once you have it to something you like, then just remember these values because we'll need them later. All right, so now we can go ahead and test out the other texture. Okay, so we'll take our texture here and we'll change this to our, let's look for fire, wherever that is, or T fire. So there we go. There's our fire effect. We can see that's pretty intense, right? You might like that, you might not, which is why, we have these other parameters you can mess with. So we can change up, some of the density, kind of where the radius starts, right? Something like, let's try 3 and 3.6. That's a little much. 3.65 maybe. So something like that, right? I think that looks okay. I'm happy with that, so this is probably what I'll go with. I'll go with these values of 3 and 0.65, but you can certainly go with, whatever you like. Okay, so we'll just go ahead and reset our blendables array. Okay, and we can actually get rid of this instance now. We don't need it. We'll delete that and just save everything. All right, so now that we have our effect graded, we can actually start, setting up the scripting or the blueprints that will add that to our screen depending on our character's temperature. Okay, so let's go into content, blueprints, core, and open up our survival character. Now basically we need to create our dynamic material instances on event begin play so that we have them and we're able to work with them right away. So we'll take event begin play, move this guy up because we're going to need to do a lot of work here. Going to move this as well. Okay, change it up. Okay, and let's comment this out really quick. So hit C, and then we'll say initialize weather / temperature functionality. That'll work. Okay, so let's add a new pin. Now, what we'll do is we'll create a new function, and we'll call this create status. No, not status. What am I thinking? Create heat. Is that what I want to do? We'll create the hypothermia one first. So create hypothermia MI. Okay, material instance. All right. So what we're going to do with this is we're going to drag out and we're going to say create dynamic material instance. Okay. Now for here we need to select a parent, so we're going to select that blend effect that we made. Okay. And then from here we're going to right click, say promote to variable, and with this guy we'll say we'll just call this hypothermia DMI. Okay, for dynamic material instance. And then from here we can take this guy and we're going to say set texture parameter value. Okay, so now if you recall in the material that we created, let's go find it and open this up. So any kind of parameter values that we want to edit, like this blend texture or the alpha or the gradients, right, or this texture U and V, okay, we need to enter in the exact name for those inside of blueprints. Okay, so our blend texture is blend. Here we go, blend. Gosh, I hate the tooltip sometimes. They always get in the way. So blend texture, no spaces, capital on both words. Okay. Now for the value here, this is a texture reference. So what we want to do is create a new variable that we'll call, let's see, hypothermia texture. Did I even spell hypothermia right? No, I didn't. Okay, hypothermia texture. And we'll go ahead and make this guy a texture 2D reference. So with that, we can take it, plug it right in. Okay, now we'll compile and save, and we'll take this texture now, and we can give it a default of our T frost. Okay, so there we go. Perfect, love it. So that's actually all for our hypothermia MI, because our default values for our blend effect, we like them, or at least I like them. If you don't like them, right, what you do is you take your hypothermia DMI here, you get it, and you'd say set scalar parameter value, for example, and you could set the gradient. Did I add a space in there? See, this is where it's really key that you name things correctly. So gradient, I did add a space. So gradient radius, and you could set this to, say you wanted 0.8 or something, right? That's how you do that. Okay, pretty simple. So, but we'll call it good for create hypothermia. Okay, and we'll go ahead and call this function off of begin play. And then we want to create another one for create heat stroke. Lord, I can't spell. Create heat stroke MI. So this one will be very similar setup. Create dynamic material instance. Selecting our blend effect. Okay, right click, promote this to a variable that we'll call heat stroke DMI. Okay. Again, we'll say set texture parameter value, and that's going to be our blend texture. And then we'll create a new variable that we'll call heat stroke texture. Take this guy, plug it in, compile, and then we'll give it the value of T fire. Okay. Now with this one, right, we liked some of a little bit different values, so that's why we're going to need to set those scalar parameters now. So we'll take this guy, we'll say set scalar parameter value, and the parameter that we want to set for this guy is our gradient radius, which I believe I liked, let's see, 0.65, I think. Okay, and now we want to do, same thing again, add another one, except this time it's not radius, it's, what is it, density. Yeah, it's density. Okay, plug this in, make sure you plug in the target, and then the value for that was like 3, I want to say. So compile and save, and there we go, so that's good. Alright, so we'll take this, add it to the end, plug it in, compile and save, and we'll just give this a comment saying creating dynamic material instances for status effects. Okay, perfect. So next let's go ahead and go into our update body temp function. Okay, so at the end of this, right after we set the body temp, what we're going to do is we're going to create some functions that will check kind of where our temperature is at. If our body temperature is way above our heat stroke limits, then we'll apply our heat stroke. If it's way below, then we'll do other things. I guess one thing, no, yeah, we're not going to do it anywhere else, we'll do it here. Okay, so what we'll do is go to function, create a new function, and we'll simply call this check for heat stroke. Alright, so there he is. So in this check for heat stroke, we're going to do a branch, and we're quite literally going to check if we have heat stroke. So we're going to say body temp, is our body temp greater than or equal to our heat stroke temp? Okay, which I believe is 104 degrees Fahrenheit right now. Okay, so if it is, then what we're going to want to do is we want to take our camera here, because our camera has some post-processing effects on it already. Okay, so we're going to take that and we're going to apply some post-processing effects to it. So since we're working with blendables, all right, which if you recall in that array, right, was where we added the material instance and such, that's what we're going to be doing here. So we're going to say add or update blendable. And what this does is it takes in any blendable object. And if you're familiar with how inheritance works in C++ or just blueprints in general, I guess, anything that inherits from a specific class can be passed in. So this is using an interface, and the interface is on basically any variable that is a material or lower than a material, I guess, or a child of a material. So that includes our material instance dynamics here, or dynamic material instances. So with that in mind, we'll go ahead and take our heat stroke one here, plug that guy in, and you see it works, right? It works because it inherits from that, or it implements that interface basically. So I just accidentally moved that guy. That was my bad. All right, and we want the in weight to be 1, because that's basically telling us to apply the effect in full right away. But if you recall, right, our alpha value is set to 0 by default, so it won't show up yet, which is totally fine. That's kind of what we want here. Now let's also handle the false while we're at it. We're going to take this same exact thing, plug it in, except we want to set it to 0, so no effect. Compile and save. Now we're going to add another function that we'll call update heat stroke. Okay. Now what this function is going to do is it's going to update that alpha value on our texture here based on kind of a percentage value, which we'll define in a second. But first, what we're going to do is we're going to take our body temp, and we're going to say body temp minus, and then we want to subtract our body temp from, is this what we want to do? Yes, we want to subtract our body temp from our heat stroke temp, because you know, this is assuming that our body temperature is at or above our heat stroke. Okay, so by subtracting these two, we can determine how much above the heat stroke temperature we are. Okay, so say our body temp is 104 or 105, right? Heat stroke temp here is by default 104, so that will give us a value of 1, which is perfectly fine. So now with this, you know, result, what we're going to do is run it through a division. So float divided by float. Now for this value, right? What this value is going to be is it's going to represent how many temperatures above the heat stroke temp that you will allow your character's body temperature to go until the full effects of you know, our heat stroke are applied. Okay, so for example, let's say you want it to be able to go from 104 to 109, right? So that means you'd set this to 5, so you divide this by 5, okay, and then we want to clamp it, make sure it doesn't go above you know, 0 to 1. Okay, we want to make sure it stays within that range because we're using it as an alpha. Okay, and then yeah, so what we'll do here is we'll actually promote this to a variable so that we can edit it elsewhere. So I'm going to right click, promote this, and I guess I don't really have a great name for it, so I'm going to call it heat stroke effect coefficient maybe, or divisor, or you know, whatever you want to call it really. It's probably a crappy name, but as long as you understand the idea, that's all that matters. Okay, so next, since we have this value now that will be between 0 and 1, we're going to take our heat stroke DMI. We're going to say set scalar parameter value, plug this in, and our parameter is going to be alpha. Okay, hook that up, and there we go. That's all we really need to do. Pretty simple stuff. So we'll go back into check for heat stroke. So in here we'll use this update heat stroke. Okay, now the last thing is we as one of you guys suggested, is to have our heat stroke kind of affect our thirst. Okay, so if we go ahead and look in our variables at our attributes in thirst, you'll see we have these two values. We have thirst depletion rate and thirst depletion amount. Okay, so depending on whether or not you want to increase how fast thirst decreases or how much decreases, you can change one of those values. So I'm going to go with the thirst depletion rate. So I'm going to take this, I'm going to get it. Okay, I'm going to do a division. I'm going to say float divided by float, because if you look at it, by default it's set to 5 seconds. Okay, so this is how many times it occurs you know, in seconds. Okay, and I'm going to divide this by 2, so that will make it every 2.5 seconds it will subtract deplete amount. Okay, so then with that in mind, we'll drag it out and say set thirst depletion rate, and there we go. Okay, but we don't want this being called every single time, right? We only want it called once, so we're going to do a do once, like so, and that's all we have to do. Now, when the effect is removed, we just need to reverse these effects, and then we need to reset the do once. So we'll delete this, and say we need to multiply. So float times float. This time we'll multiply by 2. Plug this guy in, and there we go. So there is our heat stroke effect in action. Okay, so we'll be able to see that after we do the hypothermia now. Okay, so let's go ahead and in our update body temperature function, we will add the check for heat stroke. Plug that in. Now, same exact thing that we did for our heat stroke, we're going to do all of that now for the hypothermia. Okay, so I know this is kind of a long, getting into, you know, a long video here, but I hope you know, at least are enjoying some of this, or you know, the outcome, which we'll see soon. Okay, so I'll try to speed it up a little bit here since we've already gone over this. So we'll create a new function, then we'll call it check for let's see, hypothermia. Okay, check for hypothermia. Now this is of course going to do a branch. All right, and what we're going to check is if our body temperature is now below. So we're going to get it, and we're going to check if our body temperature is less than or equal to our hypothermic temp. Okay. So similarly to how in the check for heat stroke, how we updated the blendables and such, and then called these functions, we're going to do the same thing. So we'll just take everything here, copy it, go into here, paste it, right, saving ourselves some time, plug it in like so, and then we'll just replace the heat stroke DMI with our hypothermia DMI. So we'll take that guy, drag it to the edge there, so that it replaces it like that. Okay, perfect. Next, what we need to do is create our update hypothermia function. So we'll call this update hypothermia. Why can I not spell? Okay. So now in this function, what we're going to do is a bit of a flip-flop on in terms of how we do the subtraction. We're going to actually take our hypothermic temp first, and then subtract this from a body temperature, because this is assuming that our body temperature is now below the hypothermic temp. Okay, so again, what we're going to do is a division. Okay, we're going to divide by some number that will get us a percentage, and that number will be the value of our temperature that we will allow our character's body temp to fall below before the full effect is applied. Okay, so I'm going to say maybe 10 degrees below. So this is 95. So if it gets to 85, then the full effect is being applied. So we'll promote that to a variable, call that hypothermia effect coefficient. Am I even like remotely close to anything? Coefficient. There we go. Lordy, it's been a rough day, guys. Okay, so then we'll take this, run this through a clamp again, make sure it's 0 to 1. We'll drag out, or actually before we drag out, we need our hypothermia DMI here, because we need to set the scalar parameter value. For the parameter name, we choose alpha, and the value is our return value there. Plug that guy in, and awesome. So we've got that working for us now. And I'm going to move this back to where it belongs, right there. Okay, so we've got all that. Next, we'll go back to our heat stroke, or excuse me, our check for hypothermia, and we'll add that function in. Okay, here he is. Now, what I was thinking of doing for kind of the adverse effect, or the bad effect, I guess, that gets caused when you have hypothermia is we're going to start, I guess, subtracting some health. Okay, some kind of things you could do. You could apply like a camera shake to your character to make it look like they're shivering. That might be something we can do later on, which is pretty simple to do. You could also make animations slower by using like a global variable for play rates, right, for animations, and that'd be pretty simple as well. But for this, we'll go with the temperature. So what we're going to do is we're going to drag out. We're going to do a branch. And thankfully, because of how smart we are, we created a function where we can check if a health timer is already active or not. So we'll get that, plug it in. Okay, and the reason this is good is because we want to make sure that before we start any timers ourselves, right, we want to check if there's already a timer playing, because if there is, then we'll just add on to the effect rather than starting a whole new effect, which could potentially be more difficult to control. Okay, so if it's true, right, if there is one, then we're going to say set health, let's see, what are we doing? Health depletion amount. Okay, I believe that's what we're doing. If we go check out our deplete thirst, for example, we kind of want to replicate this right here. So we can actually just copy this. How about come back into check for hypothermia. I'm going to delete that guy and just hit paste, or Control V, to paste. Okay, now if it's false, then we're going to say set health timer. Look at those awesome functions that we already have. Loving it. All right. So now whenever we turn off the effect, right, we want to make sure that we reset whatever happened up here. So the way we do that is we need to check two things. We need to check if our thirst timer is active and if our hunger timer is active. Okay? Or we need to check if either or are. So we'll do an or. All right? Because if either of them are, well, if one of them isn't active, right? Maybe that's the better way we should do this. Okay, so yeah, actually we do want to use an or. So we're going to do an or. And basically what this is going to tell us is, it's going to say if either of these are active, right, then it'll return true. Okay, if both of them are inactive, it will return false. Okay, so we'll do a branch, and off of the true, right, the true meaning that at least one of them is active, okay, then we're simply going to reverse what we did here. So we can just copy and paste this. We'll take our health amount here, do a float divided by 2, plug it in. Okay, now if it's false, meaning that both of them are, inactive, then we know that there's not a current timer going on, so we just want to clear the timer instead. So say clear timer by function name. And I realize now that we probably should have created some clear functions for all of these, but I guess it's a little late, or not late, but we don't really need it at this point. Okay, so object will choose self, and for the function name we'll choose health timer name. Now, I think this should work pretty well. If it causes us problems later, then we'll just come in and fix it. Okay. So there we go, we have that. We'll go back into our update body temp. We'll add that function called check for hypothermia, plug it in, and now we are ready to test our effects. Okay. So what we're going to do to test it is I'm going to take our little modifier here, and I'm just going to set this to some kind of ridiculous value. I'm going to say like let's do like 150. Okay, so I'll change our world temp to 150 degrees, which is really hot. So if we press play, we'll go ahead and so you see our world temp is 76.8, our body temp is 98.6, okay, 98.7 now. But if we walk in, okay, world temp is now 150 degrees Fahrenheit, which is insanely hot. Our body temp is going to start skyrocketing here, so it's already 100.4. So once it gets to 104.0 or above, it will start to interpolate, or add that post-processing effect from 0 to 1. So you can see already on the edges it's starting to be applied as our temperature increases. And since we specified our little coefficient value to be 5, right, the full effect will be applied once we reach 5 degrees over 104. So at 109 there, we hit the full effect, and now we're just burning up really bad. Okay, and our thirst depletion rate has increased. Okay, it's got a little hard to tell, but every 2.5 seconds it's being fired now. And now if you look at our well, as we drop back down in our body temp, right, you'll notice that the effect will fade more. So we'll just wait for that to happen a little bit. So it's getting back into night, dropping down the effect. Okay, awesome. So we know that's working. Now let's try out the hypothermia. So we'll set this to some absurdly cold value of like maybe 0. Okay, we'll press play. Go into our little volume. It's now 0 degrees. It's going to start getting very cold. And now once we get, so this one, right, we set it up to interpolate between a value of 0 and 10 degrees below our, below hypothermia. So as you can see, the effect is starting to be applied. Okay, it's a lot more subtle now because we have such a wider range, I guess. We have a whole extra 5 degrees to interpolate between. So it's definitely dropping. Our character's definitely getting cold. Okay. And once we get below 85, the full effect should be applied. So we are now dead, actually, because hypothermia has killed us. But it's saying that in the top there, top left, for our health. So that's fantastic. But as you can see, it's working. And that's really, the point here. We wanted to make sure that this works. So our body temperature is also going to go back up, and the effect will fade away. Okay. So there you have it. Sorry for the long video. I know it was probably a really long one, but I hope that you guys liked the video. If you like it, like or subscribe, and I will see you guys in the next one.